Welcome to the Listen, Learn, and Lead series of interviews with extraordinary leaders here at Naval Postgraduate School. Our faculty are part of the magic here at NPS, where they come together with our operationally experienced students and develop solutions and really work on innovative and creative ways to address the challenges and the opportunities in our naval forces today. Today I am pleased to speak with three leaders from the NPS Center for Additive Manufacturing. With me today are Doctors Emre Gunduz from the Mechanical Engineering Department, Amela Sadagic from the Computer Science Department, and Geraldo Ferrer from the Graduate School of Defense Management. And that's one of the absolute magic also of NPS, the interdisciplinary approach that we have with our faculty and our students across the intellectual span of our institution, solving in multidisciplinary ways many different kinds of problems. So just this week, NPS and Xerox announced a new strategic collaboration focused on advancing additive manufacturing research and the installation of Xerox's first liquid metal printer, which has a potential to dramatically transform the way that the military supplies its forward deployed forces. But first, I would like to have each of our guests today talk about their background, what brought them here, and the kind of work that they do here at NPS. So let's start with Dr. Gunduz. First, sir, your background and what brought you here and the work that you're doing here.
Thank you, President Rondeau. My name is Emre Gunduz. I'm an associate professor at the Mechanical and Aerospace Engineering Department. I'm also the co-director of the Center for Additive Manufacturing at NPS, along with Dr. Sadagic. My research is on additive manufacturing of energetic materials and metal-based systems. My background is on materials science and mechanical engineering. A lot of my research involves with materials development and additive manufacturing platform development for different applications.
And you came from Purdue University, correct?
Yes, prior to NPS, I was a faculty at Purdue University. I worked at the Zucrow Labs on energetics and propulsion work.
Great, thank you. Dr. Sadagic, please, about your background and what you do.
I am Dr. Amela Sadagic, Research Associate Professor in Computer Science and Modeling Virtual Environments and Simulation Institute. And I also have a role of co-director of NPS Center for Additive Manufacturing. My expertise is in virtual reality, augmented reality, human factors. We do all kinds of studies where we examine efficiency and effectiveness of range of systems, most of them training systems. And my interest in additive manufacturing came through adoption of technology. Before I was studying adoption of training simulations in DoD, and those insights were crucial to bring to study of adoption of additive manufacturing. And the other aspect of interest in additive manufacturing comes from potential that we can use virtual reality and augmented reality to do rapid prototyping in additive manufacturing.
Thank you. And Dr. Ferrer.
Well, I'm Geraldo Ferrer, and I also have a degree in mechanical engineering for undergrad. I worked in the petroleum industry for 7 years. And then one day I decided to get my MBA. I came to the United States, did my MBA at Dartmouth College. And I decided that what I really wanted was academia. And for that, I did my PhD in technology management. After 7 years at University of North Carolina, I came to NPS to be a professor of supply chain management. And it was at about the same time I became an American citizen. And so I've been at NPS for 16 years teaching supply chain management. And a few years ago, I saw additive manufacturing as the game changer that could change that could improve the supply chain of spare parts at sea.
So that's a great segue into my next question is manufacturing. If you use that word in all kinds of places, they think about large business, large buildings that they make things, and in the old days you have, the spewing forth from the smokestacks, but then there's a view about manufacturing that it feels like an old word. And yet now, with the additive manufacturing and all the things that we're doing, this is now a new word. It's a new phenomenon as to how we look at materials. Can you talk a little bit about how that does affect supply chain, for instance?
Yeah, absolutely. The field of supply chain management actually is started as a support of manufacturing operation. So the concern is being of how to have the right supplies at the right place at the right time so that you could make the items that you want to make. Now, for the Navy, what you need is the right spare part at sea, and then you don't have a lot of flexibility. How are you going to do that? And so additive manufacturing really makes the possibility of transforming how you get things available the moment you want. You simply make it. And obviously we're not there yet. But that's what, from the point of view of defense management and supply chain management, that's what we're looking for in additive manufacturing, the day that we're going to have that full capability.
So we go from there about what we have for a supply chain, and we go to the notion about at sea, okay? So we're here at Naval Postgraduate School, this notion of needing things at sea. There seems to be two different things here that I would be interested in all of you talking about, and that is both the fact that sailors at sea need to fix things. And I know for a fact that they yearn to go back to being able to fix things rather than having the plug and play and popping things in and out, but to fix them rather than to replace them. Now also there is an innovation going on at sea of things they had never had that now are useful. So would you three talk about that a bit in terms of innovation at sea and making things at sea? And why don't we start with you, Amela?
Oh, I'd be happy to expand on that. Innovation by sailors and Marines and soldiers, all services really, is a very important part of manifestation of additive manufacturing. Unlike many other technologies where you get a complex product and there's very little you can do about it. For example, big training systems, maximum you can do is to tweak a little bit of a training scenario. But you cannot invent everything from scratch. In additive manufacturing, that is possible. And so talking about Navy has, together with Marine Corps, of course, has a whole range of laboratories that are made available to sailors and Marines so they could come and do innovation. They receive training there, and they start innovating in terms of developing parts or even tools that never existed. And so our unique capability is to visit those places, talk to those people, collect the data set, and we have numerous examples of those parts and tools, as I said, never existed, but made as innovation by sailors and Marines, saving time, resources, and certainly money.
And before Emre, I know, wants to come into this, but can you give me an example? You talked about some examples, a story.
Well, I can reflect on a story of one vessel where there was no specific wrench for the bolt that they had. They had very few bolts of that kind, and sailors had to find a way around with different kinds of tools. And because they had access to metal printer, they decided to make their own custom-made wrench. And so that was clearly one way to address missing resources. Another example that I vividly remember is one maintainer who needed to climb a big structure and bring 5 tools with him to make certain repairs and conduct maintenance. He decided to fuse those 5 tools in one. Yeah. And that had its own parts, specific design. And so instead of taking 5, risking that one will drop from height, he has only 1. So those are kind of ingenious solutions that sailors are coming up. So more they have access to that technology and way of thinking, they are coming with more and more examples.
The way of thinking is really a byproduct of all that, isn't it? No matter what they made, the fact that they made it and went through that process of thinking about it. So Emre, what would you say about that kind of phenomenon?
As part of my background, I'm more interested in the technical aspects of that kind of adoption. So one important part is having material systems that have adequate properties that can be used on board the vessel. Another thing is the printing system that can operate under those conditions in a satisfactory way. For some parts, it might not be critical, but for some other parts, that's an important consideration. So my research is involved with more on the technical side, materials development, and how those parts that are printed, what kind of properties they have. That's an integral part of that process.
There was an article written, though, that said that your method is a game changer in several ways as to how you do these things, and that it allows for printing of viscous materials in existing high-performance systems that previously lacked the ability to print these materials. Mm-hmm. So what's that mean, and can you give us an example of that?
Sure. A lot of rocket propellants consist of these powder ingredients mixed with a binder. And they will have typically a lot of particle with little binder just to hold them together. And being able to print these systems is really challenging due to the viscosity of the material. So my prior work and my continuing work here, we figured out a way to be able to extrude these materials very quickly at a high resolution. That enables you to print really unique parts with customized geometries that makes most use of the energetic content or other properties of the materials you use. So you might be using the same materials, but you gain a lot of advantage just by changing the geometry and your composition, which is a big advantage.
That is a fabulous point. So when you all are together in this group, and it's interdisciplinary, and you talk about the different domains, and that not every domain can be all things to all people and all clients, but there must be enough to each one. What are your conversations when you talk about that in the supply chain area, when you talk about that in all of the other areas with regard to making things, and when you discuss it with regard to materials? What are your conversations about, gosh, this is a good idea, or no, that's a bad idea? What are the conversations that you have amongst yourselves?
That dialogue manifests, the dialogue that we have is a very good example why the value of interdisciplinary research. I think that interdisciplinary research can have the biggest quality if we have shared language. And so that's what we are trying to establish and understand. So I may be familiar with return on investment, but I'm not expert in that. However, I can bring my knowledge of what matters to human users to that domain to enrich expertise of my colleagues. So what we try to do is to expand the number of projects where we have more than one expertise, more than one. Sometimes it's not possible to have everyone involved, and so 2s and 3s and 4s is certainly something that we try to bring in projects, and we have that type of project in the past, and we still have them. There's also a whole new domain that we would like to bring to the fold. Those are sensor technologies, artificial intelligence, data science, robotics. So there's a lot to be done in the future, and we hope you'll hear from us more in the future as well.
So if everything were that would accommodate this would be in place, what do you think would be one of the great breakthroughs Geraldo, if you had all of this and it would make the supply chain different?
Yeah, there are two possibilities ahead of us. One is the additive manufacturing support of weapon systems that are out there that already exist. And then there is the additive manufacturing support the weapon system of the future. So I believe that, we already see it happening, that new products are being designed with additive manufacturing integrated into their planning, their manufacturing planning. And especially in aviation and space systems and so on, because of enormous weight savings. I'm actually talking to their specialty, but that's the greatest benefit of additive manufacturing, is the reduction of weight, and sometimes improving its strength. So that's an opportunity that new weapon systems will have more and more. And at that moment, now answering to your question, what's the opportunity there, is that when it comes the time to provide the maintenance to these new weapon systems, we will already have the printing files for all of those parts, big and small, that sooner or later will fail after so many times of usage. So that's the future out there, where I think we're going to be in a few years.
So I'm a history major here, so we are having a hazard here on my own competence. But it does strike me that this conversation moves manufacturing and the making of things not only from stamina, persistence, and endurance, but also to movement. So that, for instance, the Commandant of the Marine Corps just recently said we need to begin to think about things as throwaways, and then how you quickly will recover, so you can throw away something and quickly make it again. So that you get into this notion of manufacturing as a movement as much as endurance. How is that right? I've done some history study of militaries over time, and certainly different things like speed and density, certainly those kind of things of the propulsion systems, energy systems change military dynamics and the nature and character of militaries. What do you see for a new military, or a new Navy or a new Marine Corps, with this kind of thing of lighter weapon systems, maybe going from hard kill ordnance to something else, and that maybe the speed of being able to make something is the tactical advantage? Talk to me about that.
So with additive manufacturing, what we have is unprecedented capability to make things when we need them, just in time. And I find interesting parallel with training in time. Training somebody so that they can use skills in 2 or 3 years, well, those skills will deteriorate, is not a really a winning recipe. But training something just before they are going to need those skills is a new way to approach, alternative way to approach. Similar is with production, manufacturing of the things. So making them just when you need it, not carrying them, as my colleague suggested, not carrying them with you all the time, and you need to have a gigantic ship for a lot of spare parts. And there's also a great value in self-sustainability. You are your own supplier whenever needed, and you don't have to wait for spare parts to be shipped to you. So you can increase your readiness several times higher.
So I do not know how much you have in terms of the sense of the history of the supply system at sea and tender supply ships and store ships. You know, the old ships that do all kinds of work. They almost like a floating factory. Okay, Do you see the rise of that, the revival of the ships at sea that are actually manufacturing ships?
Oh, that's, I haven't thought about it, but it's really inspiring. I can see that easily happening. So that complements well what I had in mind before. What I thought was that the larger ships, certainly the aircraft carriers, but many of the others with more space, they would have their own shops that would support the rest of the battle group. But you could have those large supply ships with much more capable manufacturing capabilities, where they would have a large variety of machines. One thing we didn't mention, and it's an expertise of my colleagues here. Emre alluded to having a variety of machines, but eventually it takes out space, right? And so higher temperature, lower temperature, polymers, metals, alloys, and so on. And it could be too much to have even an aircraft carrier, but if you have a supply ship that would complement that capability at sea, that would be fantastic. Yes, I could see that happening.
It's a thought. The old subtenders is what I'm saying.
But it is really a great thought.
Emre, some thoughts on this?
Yeah, as in the future, in general, everything is going to be more dynamic, and agile systems that can respond to these will be really necessary. The future of warfare is probably going in that direction, complemented with machine learning, artificial intelligence, automated systems. So AM has certain aspects that addresses those to be able to operate under those conditions. You need that kind of automated systems with large, basically it has to be very agile systems that can really respond rapidly to dynamic environments.
Amela, I've heard about the Naval Additive Manufacturing Enterprise 2030. Could you talk about that a little bit, please?
I would be happy to. So Naval Additive Manufacturing Enterprise 2030 is umbrella effort initiative that we started at NPS. It's part of activity done by our Center for Additive Manufacturing that my colleague Emre Gunduz and I are co-directors. And so that's a kind of nice home to have to fold a number of interdisciplinary research efforts to be part of that. But for us, that was more like a vehicle to advance all kind of research on additive manufacturing within NPS. We also, a part of that, very important part, is our collaboration with industry and academia, as well as a number of institutions, naval institutions. And so our work with Xerox Corporation is part of that effort.
Speaking of Xerox, Emre, I'm curious about your thoughts. So why bring the Xerox LMP here? And what is it that kind of partnership of Xerox and NPS and looking at liquid 3D printing, what does all that mean for us?
Well, we get a nice toy to play with, so that's what excites me the most. But so it's really important. I alluded to this before, but one size does not fit all. So typically, to address many different challenges, you need a variety of systems with certain capabilities. And there have been a lot of systems printing different materials and larger or smaller structures. But the Xerox system fits a different category of medium-size, like lightweight alloy production at high resolution and high speed, which makes it really attractive. We're really excited about the collaboration, and we hope our research work here is going to help the Navy's goals of especially increased operational readiness. Being able to print these parts while at sea is a great advantage.
Yeah, so I know that Xerox is very excited about how we could do these things at sea and then give them some insights about development and those kind of things. We did that through the Collaborative Research and Development agreement called a CRADA. But I know that Xerox is as equally excited about you having a toy as they are, as you are, because it allows them to have somebody who's really looking at the application of this work. So that, and you got this whole set of students. So I think it's going to be really a terrific new approach to partnerships, wouldn't you say?
Yes, yes. I think we can do a lot of science on it as well, and we want to basically investigate all these aspects of these systems and then move that further to warfare centers or other collaborators for actual certification and those kind of efforts that requires these systems to
So
go
what's
online.
great about this is when Geraldo had talked about the adoption through a network, that this is a kind of network. So if we're now helping the warfare centers and they're helping us to understand things, now we have an enterprise, an ecosystem of intellectual capacity building, and that's just terrific. This whole enterprise with Xerox was so great. It is great, and I know that they have been very, very pleased with this whole prospect as well. So I look forward to seeing the new things that you'll discover with all that.
Would like to mention, and as my colleague suggested, there's a really specific value about this printer. One is the type of material that is using, is aluminum. So we are branching out. We are expanding types of materials that we can print with metal printers.
So all of this takes, this notion about being able to teach this way of thinking. It's a different way of thinking. And so when you're in your classrooms and when you're thinking about this and you're talking about this together with your colleagues and each other in the additive manufacturing space, what is it that you think are attributes to be able to learn like this, and then not only need to learn to do, but to actually do? What do you think are the attributes that students, that operators and students need to acquire to really advance this kind of work?
I think you mentioned change of a mindset, that that people can innovate and for example, in our classes, we don't teach additive manufacturing. We have computer science, modeling, simulations. However, we extensively use additive manufacturing as tool to make one-offs props that we need for our studies. And some of those props are behind me, where we, for example, printed those heads to examine some elements of mixed reality. So projected human faces on 3D printed heads so that we can see what kind of effect can they be used as part of physical training ranges where you would like to present virtual humans, for example. So for a number of years, NPS used additive manufacturing as a tool. And so we see both kind of research going on. One where we use products of 3D printing as tools to support some other domains, and then studies that are focused specifically on additive manufacturing, like our colleagues in mechanical engineering, and then studies on return on investment or others where additive manufacturing is as a center of our attention.
So you also, when you're on the edge there of also talking about what you have passion about, and that's how the whole artificial and virtual reality comes into play too, right?
Very much, yes. And I believe I mentioned that one of our goals is to use those technology for rapid prototyping.
Yeah.
And when I think about additive manufacturing, as much as many other technologies, it's never success that was made in that particular technology. It's success that is made in a whole range of technologies. And so adoption of 3D printing, additive manufacturing, will have to follow the success of material science, success of how you make interface. If you make interface too complicated, then it's very hard to see masses of sailors and Marines being able to model those 3D objects and then print them.
So I had said to you that I wanted to talk a little bit about leadership. I think I would like to be a bit of an adjustment here and ask you three to talk to me about the notion of adoption. So this is really important to your work, and Emre, you've used the term, Amela, you use the term, and Geraldo, you use the term. So this is a common term for your discipline, this interdisciplinary approach that has to look at these things. I'm going to start with you, Geraldo, and tell me about your view of how do you teach adoption and how do leaders practice adoption?
So I have a segment in my course on RFID, which is another technology that is critical for supply chain management. And we discussed the challenges of RFID adoption. The problem with, or the challenge of a new
And
technology,
RFID is what? RFID?
radio frequency identification,
Right.
which it allows to make a unique identification of any item that we have in a supply chain. And it has several challenges, different protocols. It's not completely unified internationally and even within the Navy. So those challenges of technology adoption exist every time a new technology is invented or becomes prevalent. Even old technologies, when they start growing, and then growing across geographic territories, then we see that there are conflicts of protocols. So it's the network, at the same time, challenge and benefit. Once you have sufficient critical mass, then adoption grows exponentially. So this is one side. The other side is having the technologies significantly advanced so that there are sufficient users that will believe in it and will adopt it. And eventually, concerns like how much it costs and how fast it is, well, volume will drive progress in cost and time. But yes, sometimes a new technology, a new concept is criticized because we haven't given enough time to test it and evolve. That's something that we discuss a lot in our class when we're talking about RFID, and additive manufacturing gradually is getting in the conversation as well.
No, I think that is superb. There's lots of complications in all that, but it's really important to understand all that. I think again, that's
I have a good example.
Okay.
Graham Bell, the first guy that he sold a telephone, who did he want to call to? So the idea is you need a network.
Yeah, you
so
need network. Yeah.
To breaking that barrier of there are not enough users, it takes time.
Adoption takes a little bit of mass, a little bit of a
Yes,
network. Yeah.
critical mass. Yeah.
Emre, you talked about adoption differently. So can you talk a little bit about your view about adoption?
My focus is more on the supporting adoption rather than adoption per se, which is Dr. Sadagic's expertise. To make that a reality, you have technical challenges, and I try to address that in my research as well as my lectures with the students. So again, as I mentioned before, it comes to systems development and materials development that really makes it possible, the adoption. I try to, in my class with the students, we try to also solve some challenges, and they get to see what can you do and what you can't do with the system, and I think it's really important. And what can you do to make it better? So as part of our thesis research topics with the students, we also look at developing new systems and improving them. Mm-hmm. And it's also a challenge to get these systems on the field. And I think that's one of the large barriers to adoption. The required agility of a technology that was developed, but getting that into use is a challenge. A lot of these additive manufacturing technologies that we know of today has been developed. They have a long history, and most of them were also available in the mid-90s, yet they are not used widely. And some of the barriers for that is not just technical, but also kind of the hype and hope curve,
Yeah.
where
Hope curve, yeah.
the initial proliferation of this rising hype kind of caused a backlash. And I think that's something we need to address as well.
That's actually a great comment, that the hype can destroy the promise in many ways. Amela, this notion of adoption is one that you've been working on for a long time, but differently. So we heard about adoption and some of the constraints, the hype and hope that might kill adoption, and then the discovery of adoption that really puts you on the edge. So different kinds of layers of adoption. What is your view about adoption and leadership?
So adoption and leadership have a really wonderful connection, and we try to practice it in our work at NPS. And I'll give a very practical example. Most of our students are active duty officers, and once they leave NPS, they will be in charge of some smaller, some larger group of individuals. And so when they go back to their services, we see them as leaders of bringing innovation from NPS to their respective units. And so some of them will be practicing additive manufacturing, but their number will be small. However, most of them, if not every single one, will be sooner or later in position to influence adoption of additive manufacturing and other technologies, other approaches. And so what we took upon ourselves is to make sure that while they're at NPS, we access them through brown bags, through all kinds of events, and provide them with basic understanding and appreciation of the potential that additive manufacturing brings to DoD. And so once they go back to their units, they will be informed, they will know, and they will relate to their role as endorsers of all kinds of technologies, including additive manufacturing. So going back to theory of adoption, endorsement of individuals that are held in the high esteem and figures that are highly respected, but also making sure that sailors and Marines will have time to do training, understanding that there is a connection to supply chain, and so they don't have to go, there is alternative way available. All that knowledge may be small, but it's crucial on large scale. And so when we have masses of people understanding potential of some technology and acting to support it, then we have a change.
Yeah. So this is the magic of NPS, this interdisciplinary approach, the focus on some mission sets that really do help focus with students and operators who are themselves knowing that they've come from someplace and they're going to someplace, but three different points of view that still complement each other in this intellectual teaming is really an extraordinary thing, and then doing it with something as advanced as additive manufacturing, and then how that comes into cyber and business and acquisition protocols, and how it comes in to all of the things about virtual reality and how it goes on to AI and ML, and how it goes on to the discovery of materials and the material science, and how the physics of all of that is really fascinating. So thank you very much for this extraordinary interview and for your contributions to this new way of thinking and these new ways of adopting new thinking. I thank you very, very much for your leadership. I want to thank you for tuning in to this Listen, Learn, and Lead series of interviews. These are the kinds of conversations that go on here at NPS every day. And so it has been my pleasure to have these three experts discussing today with us an extraordinary new way of looking at science and the applied science and how it improves our world. We look forward to your return next time for Listen, Learn, and Lead.